Good morning all. In the series of lectures of gamma distribution, today let we see the MGF of gamma distribution. So by definition, MGF is mxt, which is equal to expectation of e raised to tx, which is equal to integration over the range of x, e raised to tx, fx dx. Now we need to replace the range of x as well as the value of fx. So the range of x for gamma distribution is 0 to infinity e raised to tx, and from fx the terms which are free from x, they are come out from the integration sign, and these are theta raised to n, gamma n, e raised to minus theta x raised to power n minus 1 dx. So this is equal to now theta raised to n, gamma n, 0 to infinity. We have from these two terms of e raised to power, we can have common as minus x, and hence in the bracket I have theta minus t and x raised to power as it is. Okay. Now we know that, what we know? See, we know that 0 to infinity e raised to minus theta x raised to n minus 1 dx, this is equal to, over here let me have e raised to, so 0 to infinity e raised to power minus x raised to power n minus 1 dx, this is equal to gamma n upon a raised to n. Okay. So by comparing both the values, we can get the value of e raised to, coefficient of e raised to minus x as a, and hence the bracketed term is the value of a, and which is theta minus t, and n is nothing but x raised to power n minus 1. So over here also x raised to power n minus 1 is there, hence the value of n is n only. Okay. So mxt is equal to, we have mxt is equal to theta raised to n, gamma n, then again over here the answer for this integral becomes gamma n. So gamma n as it is upon a raised to n. So theta minus t raised to n. Okay. So theta minus t raised to n. So gamma n get cancelled. We have the term as theta divided by theta minus t raised to power n. We can write this as theta minus t divided by theta raised to minus n, and hence we get this as 1 minus t by theta raised to minus n. So MGF of gamma distribution is 1 minus t by theta raised to minus n. Now since MGF is nothing but moment generating function, means by using this function we can generate the moments, that is raw moments or central moments. So the next part is we can generate the moments by using this MGF. So let me have this. So moments using MGF. So mxt over here is 1 minus t by theta raised to minus 1. So to find mu1 dash, so to find mu1 dash, the formula is dmxt dt raised to power r, and t is equal to 0. We need to put the value of t as 0 after taking the derivative. So if I put r is equal to 1, we get mu1 dash, and mu1 dash is dmxt dt. Okay. So we can take the derivative, first derivative, fine. So take the first derivative, that is derivative of this with respect to t. So what is that? We have this as minus 1, then 1 minus t by theta raised to minus 1. So it is minus 2, and the derivative of minus t by theta is again, it is minus 1 upon theta. Okay. So we have we get mu1 dash is equal to, now see, minus minus, we have the minus term get cancelled, and I have 1 minus t by theta into 1 upon theta. Over here we need to put the value of t as 0. Okay, so what we get? See, 1 minus 0 by theta, 1 by theta. So 1 minus 0 is 1, and hence we get mu1 dash as 1 upon theta. Fine. So that is my sorry, over here आता परत घ्यायला लागेल म्हणजे हे सगळं MGF घ्यायला चुकला. So we know that by the MGF is nothing but moment generating function, and by using this function, that means by using the function we can generate the value of moment. So let me find the value of moments by using this MGF. So moments using MGF. Okay. So the MGF of gamma distribution, just now we have this as 1 minus t by theta raised to minus n. Okay. So the formula for raw moment is, let me write over here raw moment. So formula for a raw moment is mu r dash is equal to rth derivative of MGF with respect to t, and we can put the value of t as 0 over here. So mu1 dash is the first derivative of MGF dt, and we can put the value of t as 0 over here. So we can have the derivative of this with respect to t. So what is the derivative? The derivative is minus n 1 minus t by theta raised to, since it is minus 1, we have the term as minus n minus 1. And again the derivative of minus t by theta, it is minus 1 upon theta. Fine. So we get mu1 dash as, so what we have, minus minus get cancelled, we have n divided by theta. Fine. The first term, and 1 minus t by theta. 1 minus t by theta. Okay. And if you observe my definition, I need to put the value of t as 0. So t is equal to 0. So if you put t is equal to 0, then the bracketed term gives me value as 1, and hence mu1 dash is equal to n divided by theta, which is the mean of gamma distribution. Fine. Okay. Now let me find the value of mu2 dash, and mu2 dash, we can find mu2 dash by using the second derivative. So second derivative of MGF, and we can put the value of t as 0. So the second derivative, that means we need to take the derivative of this term. Okay. Since this is the first derivative, isn't it? So we need to take the derivative of this again. So what we get? No, sorry, not derivative of this. We need to take the derivative of this. Derivative of this step. So derivative of this step is t. Minus minus plus. So n by theta as it is. Okay. Again, the derivative of this term, that is 1 minus t by theta raised to minus n minus 1. So derivative of this is minus n minus 1, 1 minus t by theta raised to minus n minus 2, isn't it? Derivative of this into derivative of minus t by theta, it is minus 1 upon theta. So minus 1 upon theta. So let me have simplification of this term as, we can have, out of this we have common as minus, so minus n plus 1 divided by theta, and this theta, so let me write as it is. So we have 1 minus t by theta raised to minus n minus 2 and minus 1 upon theta, and over here we need to put the value of t as 0. So what we get? See, so we get this as mu2 dash is equal to, now see, minus minus plus, and n plus 1 theta square. So n n plus 1 theta square, and we put t as 0, so 1 minus 0 by theta. That means our mu 2 dash is n into n plus 1 upon theta square. Fine. Again, similarly, I can find mu 3 dash, and mu 3 dash is third derivative of MGF, and after having third derivative, we can put the value of t as 0 over here. Okay. So over here we need to take the derivative of this term. Fine. Okay. So let me simplify the first term. The first term is n plus 1 divided by theta square. Now take the derivative of this. So derivative of this is minus n minus 2 1 minus t by theta raised to minus n minus 3 into derivative of minus t by theta, which is minus 1 upon theta. Okay. So mu 3 dash is mu 3 dash, this is equal to, now minus minus we have common and this minus, so this gives me plus. Okay. So we have terms as n plus 1 n plus 2 upon theta cube. So let me write the terms n plus 1 n plus 2 theta cube into, we need to put the value of t as 0. If I put t as 0, we get 1 minus 0 raised to minus n minus 3. So it gives me 1. Hence mu 3 dash is this n plus 1 n plus 2 divided by theta cube. Right. Now the last value, that is mu 4 dash, that is we need to take the fourth derivative of your MGF and put the value of t, put the value of t as 0. So what we get? 3. So we need to take the derivative of this term now. Okay. So first of all, I have the constant term as n plus 1 n plus 2 upon theta cube. Now take the derivative of this term, and derivative of this term is minus n minus 3. Okay. Minus n minus 3, again 1 minus t by theta raised to minus n minus 4. Minus n minus 4 into derivative of minus t by theta, and it is minus 1 upon theta. So this gives me as minus minus we have common and this minus. So what I have the term as n plus 1 n plus 2 n plus 3 divided by theta raised to 4, and if I put the value of t as 0, then the bracketed term gives me answer as 1, and hence mu 4 dash is this. Okay. So that is, we are finding moments, that is raw moments, by using MGF.
Thank you for watching my video. Please subscribe my channel.